Look at the difference between like terms and unlike terms. So the first general idea here is that our terms here in this example here, we've got two different terms. We've got a 3 is one of the terms we have. We've got a 5x. Those are the two terms we have, separated, of course, by the positive. Right? If we had a negative in there, we could have a 3, say, minus 5x. Just recognize there that your two terms in that expression will be a 3 and a negative 5x. The sign goes with the coefficient right there. So like terms are two or more terms in an expression that have the same variable. They have the same variable within them. So in this case, examples of terms that would be the same as 6x could be, say, negative 2x, or just simply x, or even 4x, something along those lines, right? Examples with two variables within the term, you got negative 7ab, that could be 2ab. And of course, order does not matter, so you could say that BA is also a like term. Right? Order doesn't matter, but it's usual to leave them in alphabetical order. And say negative 3ab would work as well. They'd be like terms. This one here, we've got 4y cubed, so technically y, though unusual, would be a like term, but remember that that's just y cubed. Okay, negative 3y cubed would be a term, and well, let's put in negative y cubed as well there, just remembering that when you've got a negative, it's automatically a negative 1 right there. Oh, so not like terms or unlike terms, of course, are the opposite. So two or more terms that do not have the same variables. So we can put, basically anything that is not just an x on its own here. So something along the lines of, I don't know, 3y. Obviously, they don't share the same variable. Or 2x squared. It's good to highlight that. 2x squared is not the same type of term as 6x, right? Same idea here if we got like a 3a squared b. Not the same, right? Anything that, or just 4j, right? So hopefully that kind of gives you a general idea of what is like terms and what is not like terms. Okay, so the key idea here is that only like terms can be combined by adding. So if we look at this in particular, we've got 2x here, we've got a negative 5x here. In the same expression, we have a 3 and a negative 2. So if we combine those together, we got 2x minus 5x, or 2x plus negative 5x, really is the best way of looking at it. That's a negative 3x. And if we look at the positive 3 and the negative 2, that gives us plus 1, right, when you combine those together. Right? Another example here, notice we've got 4x squared is one type of term. We've got no more squareds, right? Our x's, we have a 4x and we have an 8x, and our constant here, we've got a negative 7. So let's combine all those together. Our 4x squared is 1. And a 4x and an 8x, so both positive, go together. That's going to be a 12x plus 12x. And then we've got our negative 7 on its own right there. There's a quadratic expression right there. So a few interesting things that can occur, and this is kind of one of the purposes of combining like terms, is that sometimes you might be able to cancel things out. Right? Take a quick look at what's going on here with the 5x and the negative 5x, they cancel each other out, is what goes on there. This is 0x, so we don't even need to write it. And we're left with just simply a 6. So simplified, that is just 6, which is really nice. Okay, and these x's here, we've got 1, 2, 3 positive x's, right? Watch out for negatives in those cases. And we've got an x squared. We can't combine the x squared with the other x's, but we have 3 positive x's. X plus x plus x is 3x. Careful, they're adding, so there's 3 of them. It's not like multiplication, which would be cubing them. And we've got a plus x squared right there. And of course, just to highlight the fact that that is the same as saying x squared plus 3x, and this form here, x squared plus 3x, would be the more normal way of writing it, the more standard way of writing it. Usually use the higher exponent at the beginning. So that's how we combine those terms, by adding them. Right? We say just by adding. You know, what we're doing is we're adding positive and negative terms. Right? So the sign belongs with the term, like we've been highlighting so far. All right, move on to a couple of examples here with the distributive property. So recall that the distributive property, all it does here is that it distributes the outside term into the parentheses. So what we're doing here is we're multiplying. Right? So to multiply, we've got 2 times 3x is going to give us 6x, and 2 times 4 gives us 8. So 6x plus 8. And a similar example right here, we get 2 times 3x is 6x again. And in this case, we've got 2 times negative 4. Remember that the sign belongs with it, so positive times negative gives you a negative 8. Right? So the sign belongs with the term that follows it, and you make sure you're multiplying the signs as well. Right? A little bit of practice that goes along with this. Right? Again, so we'll race through these. We've got 2 times x is 2x, and 2 times 3 is 6. 3 times x is 3x, and 3 times negative 6 is negative 18. Negative 4 times negative 3x is negative 12x, and negative 4 times positive 2 is negative 8. Negative 3 times x is negative 3x, and negative 3 times negative 1 is positive 3. Right, so we're multiplying the signs as well. Make sure we're doing that. Okay, so 2 times 3 is 6. 2 times negative 2x is negative 4x. Right? And this one here is a useful one here. Remember that when you've got a negative on the outside, that's a negative 1 is what we're looking at right here. So it's negative 1 times 2 is negative 2. Negative 1 times positive x is negative 1x or negative x. Right? So watch out for that sort of thing as well. So when you've got a negative outside the parentheses, that's basically a negative 1. You just don't see the negative. Right? It's not minus the term. All it's doing is changing the terms inside the parentheses is what's going on there. And if I'm going too fast, feel free to pause, rewind, take a second look at that as well. So putting it all together now at this point, simplifying this, we will work first with the distribution part, and then we'll work with the rest of it. So what we get here is we get 2 times 4a is 8a. 2 times negative 1 is minus 2. And then on top of that, we have this a separate. Okay, so we've got plus a. So 8a plus a is 9a minus 2. Okay. Again, same idea with this one here. We're going to work out with this part first, and then we'll look at the 6r separately. Okay, so on the 6r, we'll just bring that down to start with because that's at the beginning. So 6r, and then we're going to look at the negative. Negative 1 times r is negative r. Negative 1 times 4 is negative 4. And that gives us 6r minus r is 5r, and that's minus 4. Okay. Same idea again with this. We're going to work out the beginning followed by the second half of it. Right, so 3 times m is 3m, and 3 times 5 is 15, so positive 15. And then we bring down our negative 10, and we can solve this quite easily. So 3m plus 5, because 15 minus 10 is 5. Once again, let's look at this in two separate sections. Distribute first, then work on the rest. So 7 times w is 7w. 7 times negative 5 is negative 35. And then we're going to add our 3w to our 7w. So 7w plus 3w is 10w minus 35. And this one, just kind of bringing it all together really in this case, is we have this whole term right here, and then we deal separately with the second part of it right here. So our first part is 3 times 5y is 15y. 3 times 4 is 12, so plus 12. And then we've got our negative 15y and our negative 12 that we're bringing down. Notice what's going on here. Right? So what is going on here? 15y minus 15y, 12 minus 12 leaves us with 0. So we've got nothing left on that there. So that's an idea of recognizing like terms and then combining like terms using distribution as well. So any questions, please feel free to ask.